Welcome to Rayat Shikshan Sanstha's Rayat Online School Education for Junior College. Subject is Physics. Myself, Zadav VN from R.R. Shinde Junior College, Hadapsar, Pune. In today's lecture, we are going to discuss the measurement and effect of heat from 8th standard and the chapter heat from 10th standard. Now, we have already know that heat is in the form of energy, and that heat energy can flow from high temperature to low temperature, means hot object to cold object. Here the SI unit of heat energy is joule, and CGS unit is calorie. Okay, we have also discussed the modes of heat transfer. The first one is a conduction of heat. This type of mode is observed in solid. Here heat is a transfer from hot end to cold end, and for this medium is necessary to transfer the heat energy. The next one is a convection of heat. This type of mode is observed in a liquid and gases. To transfer the heat energy from one part to the another part, here also the medium is necessary. And the third one is a radiation. To transfer the heat energy in a radiation method, the medium is not necessary. The example of the radiation we can give the sun. Now, the next point is heat and temperature. Here, in heat and temperature, we can observe hot gas and cool gas. In hot gas, some atoms are shown with an arrow. That arrow shows the velocity of that atom. Now, we know that velocity have direction and magnitude also. If we observe the velocity of hot gas and cool gas, we can clearly see that the magnitude of the velocity from hot gas is larger comparative to cool gas. Means what? Here hotness is decided by the magnitude of velocity of that atom. That's why hot object having temperature is maximum comparative to cool gas. Now here solid image is shown. We know that solid is also have its own temperature or its own hotness or coldness. That temperature is due to the atoms in solid which oscillate to its mean position. They cannot move like a gas because they are tied to one another by force acting in between them. And because of their oscillation, solid having its own temperature. There is a small difference between heat and temperature. Here I can show the total kinetic energy of atom in a substance is measure of the heat contained in that substance, and the temperature of substance is the average kinetic energy of atom. As you show here, the total kinetic energy of atoms which is a heat, and the temperature is average kinetic energy. Now there is a difference between heat and temperature. First point, from heat, it is a form of energy, and temperature, it is the degree of hotness or coldness of the body. Second one is it is measured in joule, it is measured in Kelvin. The SI unit of heat is joule, here temperature is Kelvin. Third one is heat is not determined directly by an instrument, and the temperature is directly determined by instrument thermometer. It is a derived quantity, it is a fundamental quantity. This derived and fundamental quantity you can study in 11th standard. Okay, now the next point is the relation between Celsius, Fahrenheit and Kelvin. There is equation which gives the relation between degree Fahrenheit, Celsius and Kelvin. Here I am write that equation, that is F means a degree Fahrenheit minus 32 divided by 9 is equal to C means a degree Celsius divided by 5. This is the relation between Fahrenheit and Celsius. Now the Kelvin K is equal to C plus 273.15. This is relation between Kelvin and degree Celsius. We can understand this point through an example. Here we consider the human body, and normal temperature of the human body, we know that in a degree Celsius it is 37 degree Celsius. Now if we have to know the normal human body temperature in Fahrenheit, we can use this formula, that is F minus 32 divided by 9 is equal to, we know the degree Celsius temperature of human body, that is 37 divided by 5. By calculating we get F minus 32 divided by 9 is equal to 7.4. Now if you rearrange the terms, F minus 32 is equal to 7.4 into 9, that is F is equal to 66.6 plus 32. Here we get the normal human body temperature in a degree Fahrenheit, that is a 98.6 degree. Now the next is to calculate the normal human body temperature in Kelvin, and the formula is Kelvin K is equal to C plus 273.15. We know the temperature in degree Celsius, that is 37 degrees Celsius plus 273.15. We get the temperature in Kelvin, that is 310.15. Okay, this formula we are going to use in 11th standard and 12th standard also. You have to remember this formula. Now the next point is a thermometer. Here in this picture we can see the different types of thermometer. In a thermometer there is a mercury or alcohol is used to show the temperature of any object. When it is in contact with object having temperature, that mercury or alcohol expand and its level in the tube is rise, and that rise in its length shows the temperature of that object. Here we can see the different types of thermometer. The first one is a thermometer which is used in lab, having the range of 0 to 40 degree Celsius and to 0 to 110 degrees Celsius. The second one is a clinical thermometer. In a clinical thermometer, the range of that thermometer is 35 degree to 40 degree. Why this range is in between 35 degree to 40 degree? We know that the body temperature, human body temperature, is nearly at 37 degrees Celsius. So the range of clinical thermometer is this one. Now we also observe the digital thermometers. In this thermometer there is a sensor which measure the heat contained or heat coming from body directly. And the last one is a special type of thermometer which is used to measure the maximum and minimum temperature of any object. When hot object is in contact with a cold object, there is exchange of heat energy. The temperature of hot object decreases, means the kinetic energy also decreases, and that of the cold object absorbs that heat energy and its temperature is increased, and also the kinetic energy is increased. Here we are discussing the point heat energy. Now the heat energy exchange will take place till the temperature of both the object attain the same value. If the system of object is in isolated form, means here is we consider one isolated box, there is no heat energy transfer between a system and in environment, then we can observe they can attain the value or heat energy exchange between them, in between them, that there is no energy transfer from system to surrounding. Now when system is isolated, the heat energy lost by the hot object is equal to heat energy gained by the cold object. Okay, this is the principle of heat exchange. Now the next point is the specific heat. Here is the definition of specific heat. The specific heat of an object is the amount of heat required to increase the temperature of a unit mass of that substance through 1 degree. The formula of a specific heat we give, that is Q is equal to mass M into specific heat C into change in temperature, that is T final minus T initial. That is amount of heat Q is depends on mass of that object, specific heat of that object, and change or increase in temperature. Okay, that specific heat of a different substance have different, because it is defined by the specific heat C. The SI unit of a specific heat is joule per kg per degree Celsius, or CGS unit is calorie per gram per degree Celsius. Now move towards next point, that is a calorimeter. Here we can see the calorimeter. In this calorimeter is used to measure the heat content of an object. Using this instrument we can measure the heat produced or absorbed. This device contains water with a fixed temperature, means we have know the value of that temperature, and the temperature of a calorimeter vessel is also the same, that is the temperature of water and the temperature of calorimeter vessel is same. Now consider we have placed one hot object in that water or in the calorimeter. This calorimeter having an inner vessel and outer vessel, so there is no heat energy exchange between this calorimeter vessel and surrounding, because this is isolated or air cavity, we can say. Now if you place the hot object inside the calorimeter, there is a heat exchange between that hot object and or with water and the calorimeter vessel. After some time, that hot object, water and this vessel reaches the same temperature. Means what? The heat energy is not exchanged with environment. That means the total heat energy lost by that object or that hot object is equal to total heat energy absorbed by calorimeter and water. Here we get the point, that is total heat energy lost by the hot object is equal to the total energy heat energy absorbed by calorimeter and water, because there is no transfer of heat energy in between the surrounding and calorimeter vessel. Now, if we consider the mass of the inner vessel or the calorimeter vessel is m suffix c, that is a calorimeter vessel mass. Temperature of that vessel is initial temperature, that is T suffix I. Mass of the water is suffix W. Temperature of water is the same as that of the temperature of vessel, that is initial temperature Ti. And the hot object mass is m naught, and temperature of that hot object is T naught. If we consider here, that is the hot object, means we cannot consider that a hot object is having temperature maximum or larger than the water and vessel. So we can know that temperature T naught is greater than initial temperature. When the temperature is greater than water and vessel, the object lost heat energy to calorimeter and water. And we know that according to this equation we can write that is the heat energy lost, that is Q naught, is equal to the heat energy absorbed. Here we write heat energy absorbed by calorimeter and water. Now according to the specific heat we can write for Q naught, we can write m naught delta T naught into C naught, specific heat we call as C. Here for calorimeter is for calorimeter mass, that is m suffix C delta Tc C suffix C, plus water m mass of water, change in temperature of water, and specific heat of water. Here we measure all three masses and the temperature by thermometer, and we also know the specific heat of a calorimeter vessel and water. So we can calculate here the specific heat of that object, means that is C naught. To use a calorimeter we can also find the specific heat of any object. Now the next point is the effect of heat. In this effect of heat we know that expansion, contraction, and change in state of the material. If we give heat to any substance, it will expand. Here we are discussing only expansion. The first one is a linear expansion. In a linear expansion there is an increase in length of wire or rod. If the initial length of that wire or rod is L1, and at that time the temperature is T1. After giving heat energy to that rod or wire, it expands and its length becomes L2, that is its final length is L2, and at that time the temperature is T2. Here the change in length, that is L2 minus L1, is directly proportional to the original length L1 and change in temperature, that is T2 minus T1. If we remove the proportionality, that is L2 minus L1 is equal to lambda into L1, we can write as change in temperature as a delta T. Here lambda in a linear expansion is a coefficient of it is a constant of proportionality, we can call it as coefficient of linear expansion. We can write that is L2 is equal to L1 plus lambda L1 delta T. We can get a common L1 in bracket 1 plus L1 lambda delta T. So we can measure the increase in length after expansion. Similarly, we can find out the equation for areal expansion of solid. Here I am writing that the equation is A2 is equal to A1 into bracket 1 plus here I am not writing lambda, here I am writing sigma delta T. Sigma is coefficient of areal expansion. Similarly, third one is a volume expansion. In a solid. Equation of volume expansion is V2 is equal to V1 the bracket 1 plus beta delta T. Here beta is the coefficient of volume expansion. Okay. Now the next point is a latent heat. Here I am show in figure. Here we show the experiment that can give the idea of latent heat. In the first figure, the piece of ice are taken in glass beaker. Thermometer is attached to measure the temperature change. When heat energy through burner is supplied, then this ice starts melting. Here we can note down the reading from a thermometer. What we observe through that reading is shown in the graph. Now look at the point A to B. Here, before the point A, that is ice, means solid. When you provide heat energy, its temperature is raised. That is your simple observation. When you provide heat energy to any substance, its temperature is increased. But from this graph, we observe that there is no temperature change from point A to B. Means what? There during a transition from a solid phase to liquid phase of object, that object absorb. I am repeating the word, the object absorb heat energy, but temperature is not changing. The heat energy which you provide through burner is absorbed by that object, and phase will change, but the temperature remains the same. Now where this energy is utilized, this energy is used to weak the bonds in atom of solid. So we have also the same position or same situation at point C and D. When there is at point C, below the point C, the water is in liquid phase. After some heat energy given to that liquid at boiling point, here the object or that liquid absorb energy, but its temperature is not changed, but its phase will change. Now it is not in liquid form, it becomes in gaseous form. Here are some definitions of latent heat of fusion and latent heat of vaporization. The first one is the specific heat energy absorbed at a constant temperature during the transformation of a solid into liquid is called the latent heat of fusion. Now the second definition is for specific latent heat of fusion. The amount of heat energy absorbed at a constant temperature by unit mass of a solid to convert into liquid phase is called specific latent heat of fusion. Similarly, latent heat of vaporization, the heat energy absorbed at a constant temperature during the transformation of a liquid into gas is called the latent heat of vaporization. The heat energy absorbed at a constant temperature during transformation of liquid into gas is called the latent heat of vaporization. And the amount of heat energy absorbed at a constant temperature by unit mass of a liquid to convert into gaseous phase is called the specific latent heat of vaporization. Now the next point is anomalous behavior of water. When a liquid is heated, it expands, and when it is cooled, it is contract. Water shows some special and exceptional behavior. When water is heated from 0 degree Celsius to 4 degree Celsius, it's contracts at 4 degree Celsius. The volume is minimum. The behavior of water between 0 degree to 4 degree Celsius is called anomalous behavior of water. This can be studied with the Hooke's apparatus, and here we can use graph to understand this concept. Now this is the initial position, that is at 0 degree Celsius. When we increase the temperature, the liquid is contracting, and after that it will expand after 4 degree Celsius. This behavior of water we called as anomalous behavior of water. Now the next point is humidity. Due to evaporation, there is a water vapor in the atmosphere, and that makes moisture in air. That moisture in atmosphere is called humidity. You also know the formula of a relative humidity, which we have to know because we can use in physics. The formula of percentage relative velocity is the actual mass of water vapor content in air in a given volume to the mass of vapor needed to make the air saturated in that volume into 100. If the relative humidity is more than 60%, we feel that air is humid, and if the relative humidity is less than 60%, we feel that air is dry. Okay.